Good day, everyone. Today we want to consider geometry. This is an important aspect of mathematics, and so many students find this challenging. But it's a very interesting study and very simple. Just need to follow through and see how we break down coordinate geometry. And it's important you share, like, and subscribe, and also comment on how this tutorial video has helped you comprehend coordinate geometry. First and foremost, let's talk about what coordinate geometry is all about. You see, coordinate geometry is an important branch of mathematics that helps to present geometric figures in a two-dimensional plane, and then we're able to learn the properties of these figures. You see, under this study, actually, we want to consider the following. 1, distance between 2 points. 2, the midpoint of a line segment. 3, the division of a line into a given ratio. 4, the gradient of a line. 5, relationship of angles between two lines and their gradients. And 6, equation of a straight line. And lastly, equation of lines which are tangent and normal to curves. We are going to look at all of this. And you see, while I define coordinate geometry, I didn't explain what it is. I just read out. As we take each of these, you began to see what this definition is actually trying to say. We just represent, geometric figures in a two-dimensional plane, and I'll be buttressing on this when we take each of these study we want to consider. So first and foremost, we want to consider the distance between 2 points. You see, let's say we have a plane bounded by the y and the x, meaning that here is y-axis and this is x-axis. This is a plane now. And let's say we have a point here, which is point P, having coordinate x1, y1. This simply means that if you trace it along the x-axis, the value is x1. Trace along the y-axis, the value is y1. Now, let's say we have another point here, point Q, with coordinate x2, y2. This also means that if you trace it along the x-axis, you have there to be x2, and if you trace along the y-axis, you have here to be y1. So I'm looking for the distance between P and Q. That's what we are looking for here. The distance from here to here. Now you see, to do this, I have to find what is the distance along the x and the distance along the y. So along the x, what's the distance from here to here? Already here is s2 and here is s1. This will be s2 minus x1. That's the distance from here to here. What this means is that, imagine here is 7 and here is 2. What will be the interval between here and here? It will be 7 minus 2. That's 5. The same way it is x2 minus s1. For here, here is y2, please. And here is y1. The interval from here to here should be y2 minus y1. That's the same thing as what here is. So at the end of the day, let's get our PQ. You see, this looks like a right angle triangle. And because of that, using Pythagoras, we can use Pythagoras theorem. So we say using Pythagoras theorem, we know that PQ, which is like the hypotenuse in this case, is equal to opposite square plus adjacent square. And so we can say PQ square is equal to, what's our opposite in this case? Well, because no angle is given, so we can use anywhere as the opposite. Let's use the y2 minus y1 as the opposite. y2 minus y1 all squared plus the adjacent, which is s2 minus s1, again, all squared. And so we can therefore say that PQ square is equal to y2 minus y1 all squared plus s2 minus x1 all squared. That's what we have here. Let's take the square root of both sides now. Square root here and square root here. Square root cancel out, square cancel out the square root, remaining PQ. And simply we're looking for PQ, distance between P and Q. That what PQ is what we're looking for. So it's equal to square root of y2 minus y1 all squared plus s2 minus s1 all squared. So that's distance between P and Q. This is what we use, distance between 2 points. It could be A and B. So you say AB is equal to, it could be S and T, any point they call it for you. But this is the formula we use to solve it. So let's take an example under this. Example 1, find the distance between the following pairs of points. We have this, number 1, A and B, and number 2, we have P and Q. So going from our definition, I forgot to say that when we're deriving the formula. You see, these are geometric figures. And so we simply put them in a plane and then find properties. In this case, the point we're looking for here is the distance between 2 points. So I have a point and I have a point, which are geometric figures, and I find the properties of those points, of those geometric figures. The points are geometric figures. Find the properties of those geometric figures. That's what the definition of this course, coordinate geometry, is saying, that we have geometric points and we put them in a plane bounded by y and x, and then we find the properties. Like I said here, the points we're looking for is the distance between the points. So let's go ahead to solve this actually. I was just trying to come back to the definition because I said while we derive, I will explain what the definition was trying to say. So look at here now. I have number 1, A, which is 3,2, and B, which is 4,6. And so take note that your x1, this x1, y1, x2, y2. So x1, 3, and y1 is 2, x2 is 4, and y2 is 6. And so we can say that the distance between A and B now is simply going to be square root of y2 minus y1 all squared plus x2 minus x1 all squared. So in this case now, our AB is simply going to be, our y2 is 6, y1 is 2. That will be 6 minus 2 squared plus, here s2 minus s1, that is 4 minus 3. 4 minus 3. So this is going to give us 6 minus 2 is 4, that is 4 squared, plus 4 minus 3 is 1, 1 squared, all into square root. So this is going to give us 16 plus 1, all into square root. So my final answer for distance between A and B is square root of 17. So that's that for this. Number 2, we have P and Q. We are given that P is 1 minus 1,7, and then Q we are given as minus 3, minus 5. And so we can see that our x1 again, y1, s2, y2 is always like that. So our x1 is minus 1, y1 is 7, our s2 is minus 3, and our y2 is minus 5. And so let's go with our formula. So PQ, since it's P and Q we have here, PQ is going to be y2 minus y1 again, all squared, plus s2 minus s1, all squared. So our y2 here is minus 5, minus our y1 here is 7. So squared plus s2 in this case is minus 3, then minus our s1 here is minus 1 squared. So this is going to give us minus 12 all squared plus, please, our square root should still be there. Our square root should still be here too. Plus minus 3 minus minus 1, that will be minus 3 plus 1, and that will be minus 2 squared. This is going to give us, if you square minus 12, you're going to have 144, plus square minus, you're going to have 4. Put that in square root, and that will give us square root of 148. So that's the answer to this second one. That's that. Let's move to example 2. Example 2 says, if the distance between the points x, 3 and minus x, 2 is 5, find x. For this question, we've been given the distance already, and the distance is 5. And we have 2 points here. The first point is x, 3, and the second point is minus x, 2. And so from here, we can see that our x1, y1, so our x1 is x, and y1 is 3. Our x2 is minus x, s2, y2. So our y2 is 2. Going by our formula, we know that distance between 2 points is given as square root of y2 minus y1 all squared plus s2 minus s1 all squared. And so what's our y2? That's 2 minus y1, that's 3 squared plus our s2 is minus x minus x1 is x. So from here, this will give us, our 2 minus 1 will give us minus 1. So I have minus 1 squared plus minus s will give us minus 2x all into square root is equal to, the distance has been given to us already, and that distance is 5. So put 5. Now I'm going to say square both sides now. Square both sides. Why? I want to remove this square root. That will be 5 square is equal to minus 1 square plus minus 2 squared. 2x, please, not 2. 2x squared. And so from here, if you square this, you get 25. And here 2 should be squared also, because I'm squaring both sides. This square will cancel out this square root. So we are left with minus 1 squared, which will give us 1, plus, if you square minus 2x, you will get square of minus 2 is 4, and square of x is x squared. So here, I'm going to bring this one here. That's 25 minus 1 is equal to 4x squared. And that will give us 24 is equal to 4x squared. Now dividing both sides by 4. So this is divided by 4, and this is divided by 4. This will give us 6. This will give us x squared. So, and then take square root of both sides. So square root of x squared is equal to square root of 6. So square will cancel square root. So we're left with x is equal to square root of 6. That's the answer for this question. Exercise 1. You can attempt these following questions, and their answers are given as well. So when you solve, you can confirm if you are right or wrong. Midpoint of a line segment. Let's say we have a line bounded by the y-axis and the x-axis. This is your y and this is your x. And then we have a line. Let's say this line is called line, has a point here, point P, which has a coordinate of x1, y1. And it has point Q here, which point is x2, y2. Now this simply means that if I trace it along the x-axis, I have x1. And I trace it along the y-axis, I have y1. And then if I trace it along the x-axis, I have x2. And if I trace it along the y-axis, I have y2. And now let's say we are looking for the middle, which happens to be the midpoint, the middle of this line. Let's say that middle has a coordinate r, x, y. This simply means the midpoint, if you trace it along the x-axis, it is x. And if you trace it along the y-axis, it is y. Now, what we're trying to do here is to get this midpoint, this middle, the coordinate of what x is and what y is. That's what we're trying to do here. And so, you see, distance from here to here, is going to be x minus x1, because if here is 5 and here is 2, it will be 5 minus 2. So this is x minus x1. And distance from here to here is going to be s2 minus x. And now, from here to here is y2 and here is y. So from here to here will be y minus y1. And from here to here will be y minus y1. So this y2 minus y, that's a mistake. And here will be y minus y1. Now, the point is that it is the midpoint. This is the middle of this line horizontally, or this line, the middle. horizontally. It simply means that distance from here to here should be distance from here to here. Mean that x minus x1 for x minus s1 is equal to s2 minus x. And if you bring x to this side, it will be x plus x, because there's a x here before. And you bring this minus x to this side, that will be plus x. Is equal to, this s1 will come and become x1 plus x2. Eventually, we have 2x being equal to x1 plus s2. And then if we divide both sides by 2, we would have our x being equal to x1 plus x2 over 2. So this is how we get our x for the midpoint. Now to get our y, also we know that from here to here should be the same from here to here if it's actually the midpoint. That would be that y minus y1 is the same as y2 minus y. And if you bring your y here, you have y plus y being equal to y1 plus y2. And this will give us 2y being equal to y1 plus y2. Dividing both sides by 2 will give us y being equal to y1 plus y2 over 2. So you see, the coordinate of our r, which is x comma y, which is what we are looking for, is now obtained as x1. The s is s1 plus s2 over 2, comma y1 plus y2 over 2 also. So this is how we get the midpoint of a line segment. Let's take some examples under this. Example 3. Find the midpoint of the line AB with coordinates A 3,2 and B 4,6. Here we can say let C be the midpoint. And so let's get the x. Already we are given that A is 3,2 first and B is 4,6. This is our x1, y1, x2, y2. And so to get x is equal to x1 plus x2 over 2. And what's our x1? 3 plus what's our x2? 4 over 2. This gives us 7 over 2. And then we have our y, which is y1 plus y2 over 2. And that will give us y1, 2 plus y2, 6 over 2. And this is simply 4. And so we can say, hence, the coordinates of the midpoint is C, comma, the x is, it should be x, comma, y. So it is given as C into our x is 4 over 7. I'll be 7 over 2, sorry. 7 over 2, comma, 4. Because the x is 7 over 2 and the y is 4. X, comma, y. That's all for this question. Example 4. Find the midpoint of the line joining P, which is minus 3, comma, 5, and Q, minus 5 minus, comma, minus 3. Solution. Here we're going to say we are given our P minus 3, comma, 5, and we are given our Q 5, comma, minus 3. And so our x1 is minus 3, y1 is 5, x2 is 5, y2 is minus 3. And so we're going to say to get our x is given as y x1 plus x2 over 2, and that's simply minus 3 plus 5 over 2. This will simply give us 1. And then our y will give us y1 plus y2 over 2 as well. And that will give us 5 added to minus 3 over 2. And that will still give us 1. So let R be the midpoint. Hence, the coordinates of the midpoint is R into brackets 1, 1. Example 5. Find the coordinate of the midpoint of x and y intercept of the line 2y is equal to 4x minus 8. Well, to solve this, doesn't look like the previous question we've solved, but to solve this, first and foremost, let me make you understand this question. This line have an x and y intercept, meaning where the line touches the x-axis and where it touches the y-axis. Now, wherever a line touches the y-axis, x is 0 at that point. So at the y-intercept, x is 0. So just simply say at y-intercept, x is 0. If that be the case, I'm going to say 2y equal to 4x minus 8, but x is 0. And then this will give us 2y is equal to 4 into 0 minus 8. This dies off. We have 2y is equal to minus 8. Dividing both sides by 2 gives us that y is equal to minus 4. I've gotten my y. And at x-intercept, y is 0. And if that be the case, we write again 2y is equal to 4x minus 8. And then anywhere you see your y, put 0. 2 into 0 is equal to 4x minus 8. This becomes 0. If you bring this here, you get 8 is equal to 4x. And dividing both sides by 4 gives us that x is equal to 2. So I've gotten my coordinate now. My coordinate will look like this now. At first, it is for x, or for, let's take the first one we got. Since you get y as minus 4, that will give you that x was 0. Remember, x is 0, and then y is minus 4. And this second coordinate, or the second point here, that when x was 2, y was 0. Remember, now I put the x value for the y value. So x is 2 here, y is 0 here. So I've got my 2 point now. And so it's going to look like this. For instance, let me just illustrate through this graph. It's going to look like this. Minus 4 and 0 somewhere here, and 2 and 0 somewhere here. So this is minus 4, comma 0, because negative, 0 minus 4. That's my bad. And this is going to be 2, comma 0. So this is not necessary actually. You don't need to draw the graph, but these are the line intercepts the y and intercept the x. And I drew like this because, you know, your y is minus 4. So this is negative y axis and this is positive y. So minus 4 and then 0. Positive 2 and 0. If not, the s will have been here if it's negative 2. So this is just how it looks like. I'm looking for the midpoint. Let's call here B and let's call here A. So we cannot get our midpoint now. So we can say, therefore, our x1 here, let's take this at our first point and second point. X1 here is 0. And y1 is minus 4. And x2 here is 2. And y2 is 0. So with this now, we can solve this question. Since the coordinate of midpoint is what we are looking for, we can therefore say that our x is equal to x1 plus y1 over 2. And that will give us x1, 0. So x1 plus x2, please. 0 plus my s2 is 2 over 2. That will give me 1. And my y is equal to y1 plus y2 over 2. And that will give us y1 is minus 4 plus 0 over 2. That will give me minus 2. So the coordinate of midpoint is 1, minus 2. And that's that for this question. You can attempt this second exercise.